Hello and welcome to the demo of Solid Steel Parametric for SolidWorks. I'll demonstrate how to build a small maintenance platform and we'll take a look at it now. So at the beginning we start our profile function to construct new required profiles. First we start here with the U profiles. In addition, I use the offsets to set the correct position. In this case, I always want the profile to be lengthened a little on one side. Then I can just place the profile like that. On the other side, we repeat the whole thing with the second U profile. Now it's the turn of the rectangular tubes that we use for bracing. Here I use the individual offsets to determine the exact positions without having to draw a new system line. For the supports I also use rectangular tubes again, but this time a different size. So far so good. Next we come to the connections. Here we want to connect the parts by using end plates. We start at the base of the rectangular tubes with the base plates. To do this, we just have to select the appropriate profile, then we get our preview. We can change the offset direction and select the plate from our self-learning database. I have already prepared the fitting base plate in advance. Next we do the other end plate connections with the normal end plates function. As before, I'll use an end plate from our self-learning database. Finally, we want to connect the stair stringer to the U profile with an end plate. We can simply select the profile and the connection surface and the software will do the rest by itself. We select an end plate from the settings again, confirm the whole thing, and the software has automatically extended the profile here to the desired point. So far so good. That happened pretty quickly. We don't need to worry about the railing that is too short. The Solid Steel update function does this for us fully automatically. Let's take a look at that. It's amazing how fast it works. Next we turn to the other side, to the next section of stairs. For this we use our staircase functions. To place a staircase and after starting the function, we simply have to select the start line, then the end line, and the software creates a direct connection between these two lines and a preview for our staircase. The profiles and the stairs are already pre-selected. That means I can now start the more detailed configuration. And here we only have to take care of our expansion now. At the top we need a horizontal extension with a length of 1.5 meters. And at the bottom we need a vertical connection with a length of 200 millimeters. In the tab for the stair steps we can now add an additional step at the bottom to close the gap to the floor. Then we confirm this and watch the software create the stairs. Quick task again. To connect our stairs, we simply use the third end plate function to place a miter plate between the corresponding profiles. The plate is from our database again. If we already work on the corner, we see that we still need a miter cut between our profiles that meet in the corner. To do this, we simply use our cut functions to create a miter cut between the two profiles. Next, we need to take care of getting our miter profile into a proper welding assembly. Therefore, we use the welding assemblies function, and here we can add the parts to an existing welding assembly using the appropriate selection. Now we have restructured our assembly with just a few clicks. Well, next we add railings to our assembly on the left. For this we use our function custom railings. We can choose from pre-designed templates and can simply select a face and an edge of our U-profile to place our railing. In addition, we are now using offsets to move the start and end point, so the railing is placed in the middle of the surface. After confirming, the software opens the previously selected template and makes changes to adapt it to the current situation. I now repeat the whole thing on the straight surface with the same template. Then we can see how the whole railing adapts to the new situation and how it creates a second variant of this railing in our assembly. As we can see, we can save a lot of work with the railing function. We only have to design a handrail assembly once and can use it as often as we want in different situations. Next, we connect our railing assemblies to our existing construction. To do this, we simply use the end plate functions again. You have seen this before, so we do this all in fast forward. Well, that was pretty quick up to here and it looks pretty good. On the opposite side we now have a little problem because the whole thing is a bit too narrow for our custom railing function. For this I thought of something else. We simply use a second solid steel assembly that I created in advance, which represents a railing across the corner. We will now insert it with the import function. For this we simply select the corresponding assembly and it's automatically inserted in our current assembly as a copy with the appropriate settings. We now have both assemblies together in one, and the next thing we have to take care of is the positioning. A function for this is of course integrated in Solid Steel Parametric. With the assembly positioning function we now have the option to link individual sketch points to one another in order to move and adjust the sketch. We are now looking for pairs of points from the two sketches to link them together. After we confirm, the software does the rest. As we can see, the sketch has now adapted automatically, and next we have another job for our update function. Great! And our railing is ready for this side. Here too, we reconnect the railing with our stairs using the end plate function, but you already know it from the first side, so we sped the part up. Well, some clicks and we are back in the assembly and all railings are fully assembled. Next, to complete the assembly, we'll add a few more gratings. For the gratings, of course, we need a support. For this, we add a few L profiles to the assembly. As we can see, it is also possible to add further profiles to lines where a profile has already been placed. That's why we can simply place the L profile in addition to the U profile and move it to the right place with the appropriate offsets. I placed the other L profiles in the same way and now show them. Then we can just add our grating straight away. We finished our small maintenance platform and I think it was pretty quickly. In the next section of the video, we'll look at what we can do now. First, we can assign position numbers to our assembly in order to create the bill of materials and drawings. I've just started the position number distribution via the taskbar. The process behind this can take a while. Well, now it's done and here we can see an overview of our position numbers. Immediately afterwards, we can now create an Excel parts list using the export function. We can choose from many different templates in order to create different list types. So, let's just take a look at the parts list. I used a template that creates different types of listings at the same time. For example, on the first page we see a list of bolts. Also a saw list. Here we can also see the different cutting angles of our stair stringers. In the structure list we can see the assembly structure with all of our welded assemblies. In the profile list we have sorted profiles according to the profile type. On the sheet metal list we have the same for the sheet parts. And last but not least, on the quantity list we can see all the individual parts one below the other. Pretty awesome! Finally, we will now create a drawing to show how we can have Solid Steel create fully automated drawings. For demonstration, I use one of the stringers and all I have to do is select the template, enter an order number and choose a location to save the drawing. The export of the drawing is a quick task, so I'm going to open the drawing to take a quick look at it. As we can see, all the dimensions we need to manufacture the part have been automatically added. We can of course add further information as we like. Well, that was our short demo of Solid Steel Parametric. I hope you enjoyed it. If you want more information, please have a look at our website. See you next time.